Hey everyone, Jimmy Smith of Good Water Warehouse here. Better water means good water products. Let's talk water. It is important that all of us working here at Good Water Warehouse and within the water filtration industry, regardless of our individual job duties, have a basic knowledge of water filtration. We at Good Water Warehouse are a water filtration company and expected to be experts on the subject, regardless of our positions. So today, we will continue these educational videos with more on the water softener, as it certainly is considered one of or possibly the most popular product that we sell. How and why does water become hard? Well, for starters, pure water or rain is not hard. Rain is soft. Rain becomes hard through its path from the sky to our homes. So what is hard water? Hardness in water comprises of two minerals found in our earth: calcium from rock like calcite or gypsum, and magnesium found in rock like dolomite. Rainwater is a natural solvent and will dissolve anything in its path. Thus, rainwater will eventually find its way into our home's water supply, along with whatever was in the rain's path. Examples of hard water. Well, much more soap is required in hard water to conduct everyday cleaning. And that is due to the fact that soap does not emulsify well or build up a lather in hard water. Some people experience issues with their hair or even skin irritations from hard water. It usually does leave a whitish deposit on household fixtures, and in some cases will destroy a fixture. Boiling water appliances like kettles can become scaled and stained from hard water and prematurely cease to be functional. Hidden areas like household plumbing and water heater internal parts can become scaled, clogged, and need premature replacement. In fact, there are some water heater manufacturers that will void the warranty on an obvious hard water damage. A yummy looking glass of hard water remains. Rocks. What does hard water look like, you might have thought? Well, here you go. It looks like rocks and stones. It's hard stuff, and it can destroy some very important possessions of homeowners. Look at the inside of this pipe. What about these wine glasses with hard water staining? Yuck! An end of a faucet destroyed, and I'm sure the rest of the faucet is not faring very well either. But how about this inviting shower stall? Not. So, where does hard water actually come from? Let's look at the hydrological cycle. Water naturally evaporates from the ground to the sky, and in particular when the sun is out and hot. The evaporated vapors will eventually form clouds that begin to condensate into rain. The rain falls back to the earth. It'll fall on the snow-capped mountains, farmland, creeks, rivers, lakes, and the ocean. This moisture will find its way through the Earth's rock bed rich of calcium, magnesium, iron, manganese, to name a few of the minerals in our Earth. And also naturally occurring poisonous substances such as arsenic, uranium, or lead. This rain will find its way into underground streams known as aquifers. These aquifers seep into lakes and even the ocean. However, most importantly, it seeps into water wells for human consumption. Due to this path that the rain has taken, it will come into contact with the Earth's above ground and below ground, naturally occurring or man-made elements. These elements are both good and bad. The good is the influence of taste and hydration. The bad is the influence of contaminants, bacteria, or pollution. Water is a natural solvent. It will absorb or draw from everything in its path. In the previous video titled Episode 1, The Water Softener, we saw the parts required to build a softener. So, let's discuss these parts and how they work. There's the control valve. This is the brains behind the system. Then we have the mineral tank. On a water softener, it's usually referred to as the resin tank. And why is that? Because inside that tank is the ion exchange media, often called resin. Also inside the tank is a riser pipe and distributors. Then we have the brine tank, and this is where the brine solution is made using sodium or potassium chloride water softening salt. We also have the brine pickup assembly, or often called a brine valve assembly, and it's connected to the control valve with brine tubing. Finally, there is a drain line to the drainage point. Now, water enters the control valve and travels downward through the resin and upward through the riser and distributors, leaving the softener as softened water for the home. During the regeneration, the brine solution is drawn from the brine tank through the brine valve assembly and into the control valve. The brine is passed through the resin to have the ion exchange between the sodium and the hardness minerals. The excess sodium and hardness minerals, or iron and manganese if they happen to be present, is flushed to the drainage point. Softeners typically recharge at a time when no water is expected to be used in the home. A universal time to recharge has been typically set at 2:00 a.m. This is due to a water softener allowing water to the house during a regeneration, but this water is hard or untreated. Water softening salt is the regenerant, as this is used to create the brine solution which is used to regenerate water softening resin. Two types of water softening salt is available, a sodium-based and a potassium-based. Potassium-based is considered healthier to drink and environmentally friendlier, but significantly more expensive than sodium. Both are manufactured with chloride. Here are 3 brands used throughout North America. Water softening pellets are typically larger than the size of a quarter. Ion exchange resin is a synthetic man-made product. It looks like tiny beads, and if spilled on a concrete floor, are like tiny marbles. Most of us have heard the term 1 cubic foot softener or 30 grain softener, and other sizes like a 50 grain or a cube and a half. These are terms related to the amount of resin in the resin tank, thus the size of the softener. A typical package or bag of resin is 1 cubic foot. One of these bags weighs around 45 pounds. We use one of these in what is called a 1 cube or 30,000 grain water softener. Now bear in mind, the actual 30,000 grain term I just used is achieved by the amount of salt used in the regeneration. But 30,000 or 32,000 grain is typically used when describing a 1 cubic foot water softener. Okay, I knew this was coming. What in the world does ion exchange mean? Water softeners function through a process called ion exchange. Ions in water, which are natural elements found in the Earth's crust, such as hardness minerals, calcium and magnesium, are removed by this process. Also, iron and/or manganese are also popular ions removed from water with water softeners. A synthetic media called ion exchange resin attracts these ions from the water. Think of resin acting like a magnet and drawing these ions from the water onto the resin itself. An important scientific point here is that ions in nature naturally have a positive or negative charge to them. These opposite charges is what makes them attract to each other naturally. In the elementary and microscopic world of nature, opposites do attract to each other and create new forms of elements found in the Earth's crust. Water softening resin is made to be negatively charged so that it will attract positively charged ions. Calcium, magnesium, iron, sodium, potassium, and manganese are all positively charged and will attract to the negatively charged water softening resin. Additionally, these 6 ions I just mentioned have different strengths of charges. For an example, manganese has a much stronger positive charge than sodium. What this means is that it will be much more attracted to the resin over sodium. So you may ask yourself, why is this important? Well, it is important due to the fact that we use sodium to remove the manganese off the resin during the regeneration cycle. In order for the sodium to accomplish this, we need 2 of the weaker sodium ions for every 1 of the stronger manganese ions. This same rule applies for removing iron or calcium and magnesium off the resin. This sodium is in the form of pellets that we saw in the earlier slide and stored in the brine tank. So what we do is we calculate the correct amount of sodium chloride, or possibly potassium chloride if you're using that, but they're both referred to as salt, and we calculate it in pounds, and we combine the salt with an appropriate amount of water in gallons to create a brine solution to regenerate the water softening resin by removing and exchanging the hardness, iron, or manganese from the resin with the salt. The resin will now have sodium or potassium ions attached to it. During this regeneration, sodium is attracted to the resin. But in order to remove the hardness and other positively charged ions, there must be twice the amount of sodium than the amount of ions on the resin to have the ion exchange function happen. What you see is an animation of resin beads magnified and full of calcium, magnesium, and you can see one lone iron ion in red. Now, just for the sake of science, note that all of these ions that you see have a 2+ beside their elemental symbol, simply stating that they have 2 electrons. Anyhow, let's not get too caught up on the science. However, watch what happens when the regeneration occurs. Let's watch this again. The sodium ions only have a plus symbol and no 2 associated. It is positive, but weaker than the ions with the 2. The resin will have sodium replace the hardness minerals, but 2 sodium ions for every single ion with the 2 is required to have an actual exchange occur. Now, sodium is left on the resin after the regeneration. The hardness, iron, manganese, excess sodium, or possibly other positively charged ions are flushed down to the drainage point. Note that the second element in water softening salt is chloride, used in the manufacturing process. Chloride has a negative charge to it. Due to the water softening resin having a negative charge as well, the chloride is not attracted to the resin, and unlike the positive charged sodium element, does not attach to the resin and continues down to the drainage point. During the service cycle, which is when water is actually being softened, the hardness minerals attract to the resin and are removed from the water, but at the same time remove the sodium ions off the resin into the water being softened. This is why softened water has sodium in it. Note that it only took one ion with the +2 to remove two weaker sodium ions. A big shout out to our friends and partners at Pentair for the fantastic animation. Grains per gallon is a unit of hardness, and this is what we primarily use in the United States and Canada. Other countries do have different terminology to indicate a hard water level. This term was developed to express hard water and to be able to discuss and understand each other, basically. 1 grain per gallon of hard water weighs approximately 64 milligrams, which is a very small number in pounds. However, it does help us realize that hard water does have additional weight due to the minerals. Additionally, for some of us watching that need to calculate hardness settings on water softeners, we typically set the hardness as a grain per gallon on water softeners. However, water chemistry test reports that we so rely on will express hardness as a total hardness in milligrams per liter here in Canada or parts per million in the US of A. So we need to remember that 1 grain per gallon equals 17.1 parts per million or milligrams per liter to calculate our hardness in grains per gallon. Hardness levels. Here's a chart which indicates or suggests levels of hardness. The chart suggests that water is soft from 0 to 3.5 grains per gallon and hard at 7.1 to 10.5 grains per gallon. There is no doubt that this chart could be subjective or debated on the exact number of when hard water is considered very hard or still soft. But hopefully you can still see a range of when to suggest the use of a water softener. The regeneration is a series of cleaning cycles and the actual ion exchange cycle. There are many reasons why we use these cycles and how long these cycles should last in terms of minutes or what order these cycles actually occur. But that is for the water professional setting up the softener for the consumer to factor at the time of the installation. That said, all water softeners will still have the following occur within the regeneration. You can see two cycles in the drawing. Cycle 1 is the service cycle. Remember that the service cycle is when the softener is delivering softened water and not part of the actual regeneration. The backwash, indicated here as cycle 2, is when the water flow is actually reversed from the service cycle flow. This picks up the resin within the resin tank, agitates it, and cleans the resin of particulates, dirt, or sediment. Cycle 3 and 4 are the brine draw and brine rinse cycles. This is when the brine solution is drawn into the resin tank and the process of the ion exchange occurs. Eventually, all the brine solution is used, and the softener will now rinse the excess brine, hardness, iron, or manganese down to the drain. Cycles 5 and 6 are the final stages of the regeneration, where a fast rinse is performed to do a final flush of the resin and prepare it for the service cycle. On most water softeners, the water to fill the brine tank is performed at the end of the regeneration to allow for maximum saturation time with the salt and ready the brine solution for the next regeneration. This next regeneration will depend on how much water is used in the home, combined with the size of the softener and how hard the water is coming into the water softener. One final slide to look at is the twin alternating system. The ion exchange is the same, but there is no interruption of softened water like there would be on a single softener. The twin alternating, referred to as a twin alt, will use one resin tank at a time. This resin tank in use is called the resin tank in service, and the other resin tank not in use is referred to as in standby mode. The system will automatically switch to the standby resin tank when the regeneration is required for the resin tank that had been in service. Once the resin tank in a regeneration is completed, it will go into a standby mode until it is needed for service due to the other resin tank requiring a regeneration. This whole procedure of back and forth can happen at any time of the day or many times in a day. There you have it. On behalf of Good Water Warehouse, I am Jimmy Smith thanking all of you for watching, and remember, work safely and keep on smiling as it feels so good to do so. See ya!